zero, which is going to be right there, and over mile 50 feet or 20 feet. And I would encourage the note taker and the people that are actually in the stream doing the measurements to let the note taker know about any unusual circumstances that you see. You can't cover everything that you see on there. For instance, in this first section of stream, one of the things that it's going to ask you is what is the habitat on either side of the stream on the left bank and right bank. And by the way, left bank and right bank in terms of this survey is facing downstream. So right bank facing downstream, left bank facing downstream. So when it asks you for data left or right, that's how you determine left and right. So what you'll need to do to use multiple teams on this is to actually mark, I would suggest in 100-foot increments, the entire length of the stream. And the way you would do that is first get your team, a couple of teams out there, you would tie this off to something close to that culvert and stretch out 100 feet of tape. You would get a piece of this survey tape, hang it in a suitable tree or bush, and write 100 feet on it. And then if another team is doing the next piece, they stretch out their tape, mark 200 feet, 300 feet, and 400 feet. So now when the survey teams come out, and the team would usually consist of one person recording the data with the clip sheet. That person would probably stay up out of the stream and the bushes and what have you, and probably 3 people in the stream taking the required measurements and information as it's called out by the data recorder in the order that, so you're not giving him data in random orders and he's got to figure out where to put it. He's going to tell you which piece of data he's looking for next, and then you would give him that data. And so now to get several teams working, you might assign team 1 to the first 100 feet or maybe the first 300 feet. And so they would survey from 0 to 300 feet. If you wanted to start a second team, then you'd go out and look for the survey tape and find it where 300 feet is, and that team may do 300 feet to 600 feet or whatever, however much you decide you want to take on. Typically, when we did this on Miller Creek, we had 3 teams. We would work on a Saturday morning till about noon. One team could do about 400 feet. And these were all, they were all adults, so with youngsters along, you might be able to do even more.
They're faster.
That was a compliment.
Yeah, faster and more agile.
Kind of like that.
So, you know, if you wanted to get some idea how long it would take, if you figure 300 feet and you have 3 teams, then you get 900 feet running a day. I have no idea how long the stream is, so that by doing this, you'll figure that out. So maybe after we get done with the training session today, if some of the teams want to go and actually mark the entire length of the stream yet today, you could do that, or if you wanted to make that a project the next time, you could do that. But you're going to need the whole stream measured, so you can start teams in various segments.
Andy, when you're measuring the stream, do you work from along the center of the stream, then when there's a bend, you kind of follow the...
That's what we try to do. As you're laying the tape down the stream, you try to kind of keep it in the center. And sometimes when you've got those 3 guys in the stream and they have these sticks, you have this tied off, you're dragging it. If this tape wants to kind of go off to one side of the stream and not follow the contour very well, a person might stand there with this stick as it's being drug upstream to kind of force it over more toward middle. This is not a survey of, you know, of millimeters. Where, you know, I mean, plus or minus a few feet one way or another is not going to make a difference in what you're doing here. So you don't have to be that specific. But if the tape wants to go over there and the stream really bends way over here, you might grab the tape with the stick and kind of move it to center channel, and to get you a little better idea of how many feet we're doing there. Maybe we ought to talk a little bit about why we're doing this. There's several reasons. This is what you're doing here has probably never been done before, so that's kind of cool. We're going to go find out what this survey is called. is the U.S. Forest Service Scientific Method of Stream Survey Fish Habitat Relationships. So this process was designed by the U.S. Forest Service and their engineers and scientists. So the good news is you're actually working with real science here. And what this survey looks for is what sort of habitat you have in your stream will support adult salmon coming into the stream and spawning successfully, and then juvenile salmon living in this stream for 12 to 18 months and then going out to saltwater. So when you collect all this data, you'll be able to sit down and analyze it and see the good parts and the bad parts of the stream. And from that information, if you want to go to the next step of actually changing what it is, then you would know what the existing conditions are and where improvements could be made. I think one thing we ought to mention is probably the most important thing we're going to do is all go home without broken arms and deep cuts and things like that. So safety is really important, and probably some of the more dangerous things you're going to be doing is walking on slippery rocks and muddy, slippery banks and things like that. So falls are likely to be the most dangerous thing down there. So the way you prevent falling is you move slowly. You make sure you if you're in a slippery situation, you maintain 3-point contact. Who of you are mountain climbers, rock climbers? Anybody? You know what 3-point contact is? Tell them what 3-point contact is.
You got 4 limbs, so you have 3 of them connected.
3 of them are secure before you take that next step. So if you're in a slippery situation, make sure you've kind of got yourself stable, you got your 2 feet planted, you got your hand on some bush or stick or something before you try to make that next step. And what doesn't work is trying to be in a hurry, right?
And lunging.
Lunging. Oh God.
That's really good.
Yeah,
You want to
kissing
try to move
goodbye.
like water.
Yeah. Yeah. So cautious and slow. The kind of boots you guys have are not the best on slippery rocks. People that spend a lot of time in the rivers and streams, fly fishing and what have you, tend to put studs in the bottom of their boots. And beyond that, we have felt-soled boots. Felt sticks to rocks very well, and besides the felts, we put carbide screws in the bottom of the felt to prevent slipping on rocks. So the kind of footwear you're wearing today and the kind of footwear I'm wearing today is not very conducive to staying upright on slippery rocks. So keep that in mind.
So if you have cell phones in your pocket, you're probably not carrying them.
Unless your cell phone's waterproof and anything else that you're carrying, I wouldn't take it with you, because the reason that I own a waterproof, shockproof, freeze-proof camera is because I've destroyed about 6 of them doing this kind of work by dropping them in the water. Even with something around my neck, you know, I bend over and it falls out of my pocket and goes whoosh, and it's gone. Yeah, so if you know, it's your electronics, but I'm just telling you, 99% chance it's going to end up in the water, with or without you. Hey, everybody got a sheet? Let's look at the very top. So that's the first thing that you fill out when you do the survey. And we don't know the basin WIRA number, although we could find that. We know the date, so we can put the date in there, today's date. And the next thing it asks for is a time. So far so good.
The top initial, just for everyone, the photocopy I was working from, it's WRI basin number.
That's right.
Yeah.
Top left.
Yeah.
WRIA.
It's Raya 9.
Raya 9.
Raya
Yeah.
9.
And I don't even know if Raya has a basin number for this stream, but they may. Okay, and
So I think we're only having him pull it out right now.
right, he's going to do it. So the rest of us, we're here for train the trainer. So what you're all trying to do is learn what this form says. So in case you're the person on the shoreline that has to record it.
So what is the S
S time, start and finish. Okay, S and F, pass the time is the start and the finish.
So I put
Sure, yeah, you can say we're started now. Okay, so what's the next piece of information we've got here?
Stream number?
Okay, stream number, the county assigns numbers to the stream, but I think where it says stream number, we'll write Salmon Creek. Hi there, are you gonna help too? We could tie this tape to you and you could just run up the creek. Okay, so the next piece of information is survey length. So where it says survey length, I don't know this, well, the stream order, what that means is the way the scientists describe a stream is a stream that flows into saltwater would be stream order 1. If I remember correctly. Then as you go up the stream, if you reach a branch, the branch would be order 2. If there's a branch off the branch, that would be order 3. So this is a stream order 1 stream. Okay, and then the river mile, the survey length river mile. Today we're going to try to survey river mile 0, which is not really 0, so we'll call this 0 at the bridge, but in our notes it ought to say river mile 0 is at the culvert at whatever this road is with enough description so that if you've never seen this before you can figure out what we're talking about.
And you said it was stream order 1, right?
Stream order 1. Yeah, stream order 1 is the stream or river that flows into the saltwater. It's got a branch or a creek coming into it, that's stream order 2. If that stream has a branch, that's stream order 3.
Okay. Weather conditions?
Weather
Cloudy.
conditions. Partly cloudy and
Or partly sunny, depending on your
our point of view.
or half
Yeah,
empty.
and
Cool, light breeze,
45 degrees.
What is this street name? Is that
and pink light breeze,
Light breeze?
That Shorewood Drive.
in Sherwood Drive.
Shorewood Drive.
And this would be north, right?
North,
No,
Sort of there,
it's still
that
out
way.
there.
kind of that way.
Close enough, guys.
Yeah.
Yeah.
Okay, I'm gonna say it starts at the culvert north of Shorewood Drive. Right?
Yeah, and then maybe note the sewage treatment plant. That's a pretty good landmark. And if you had an address, you could add that or the sewage treatment plant, and you can do that kind of thing later. What's the next piece of data here? We have,
Investigators.
okay, we have the weather conditions, mostly cloudy, cool, and what, 48 degrees, okay? And investigators. So now here, what we're going to write under investigators is the name of the team leader or the data recorder, and the fact that that person is the data recorder, because subsequently 6 months from now when we're compiling all this information, if there's a question, you can't figure out what the writing was, you'd want to get a hold of the person that wrote it and ask them, you know, I can't read your handwriting, what does this say here? And then besides that, the name of the 3 people that are in the water providing the data. So that's what would be under investigators.
So what do I do there now?
Okay, so you would write your name, print your name, and after that in parentheses, team leader or leader, and then we'll add the 3 names of whoever's going to get in the water and take the measurements for you.
So today we're just doing 0 to 100, correct?
Today we'll do 0 to 100 as a training exercise, yes.
Okay.
And what that means, a training exercise, what's going to ultimately happen is you're going to decide whether you want 2 teams to do this or 3 teams or whatever. So that means that, you know, some of the people here are going to be team leaders and have to take a team up here and do a section. So I think what we'll do today is we'll start with him as the data recorder and the team leader, and if somebody else would like to step into that role as we go and record some data so you can just get some practice, we'll do that. And then the people that are in the stream, if you want to switch them out, we can do that also. Okay, next piece of data. RF, and RF is the reference number. You don't really survey this stream like you'd think. You don't survey it by saying from river mile 0 to 10 feet, you have this situation, and from 10 feet to 20 feet, you have another situation. What RF means is that is just a numerical order of data points. So the first RF, which means, what does RF mean? Reference point, right. So what RF means is that's a consecutive order of numbers. So the first one would be number 1. And what we're looking for is where the stream changes character. And what I mean by that is when we look down here in the stream, well, that section of water will either be a riffle, and the definition of a riffle, which is on this paper that I gave him, plus it's also shown on these cards, which I only have one copy of. A riffle is a piece of water that's flowing, that you can see agitation on the surface due to rocks and things that are under the water. So in other words, it's kind of a fast, choppy piece of water. And we'll use the word, I'll use the word glide and run kind of interchangeably. A glide or run is another kind of water in the stream where the water is flowing, but it's smooth on top, there is no agitation. And then the third kind of water we're going to be looking for in the stream is a pool. And I think everybody pretty much has an idea what a pool looks like. That's a deeper section. A run or glide is deeper than a riffle. A riffle is typically shallow. A run or glide is a little deeper, and the rocks on the bottom don't have any influence on the surface of the water. It flows over without agitation. A pool is deeper than both a riffle and a run or a glide, and is usually characterized by smooth water, some back eddies. And now in the Forest Service way of doing things, they have broken, for instance, find a good example here, pools into a whole bunch of different kinds of pools based on how they're formed. They have a pool described here in this picture as a dammed pool. So what that means is that there's some obstruction, log or what have you, or man-made thing in the water that makes a dam, and the water plunges over there and it causes a pool below that dam. Or actually the water behind the dam is also considered a pool. So in this case, what they're trying to describe here is a pool that's created by a dam. It could be a reservoir. They also describe a mid-channel pool. So in other words, this mid-channel pool is not the size, the deepest part of the pool is in the middle of the stream, and it may not be as large as the entire width of the stream. They talk about plunge pools. A plunge pool might be where you have a log or some rocks across the stream, and the water flows between them and cascades down and digs a hole. And so forth. Now for runs and riffles and all that sort of thing, the Forest Service, when they're doing this survey, breaks all these different parts of the stream down into all these minute pieces. We found that in our survey that was too much information. We were kind of messing with our brain with that much data. So basically what we did was, when you look at a section of stream, you decide if it's a riffle, a glide, or a pool. Those three basic things, without trying to define them any further. So when on this first section, reference number 1, we're going to look at the stream right where it goes into the culvert there, and we're going to decide whether that's a riffle, a glide, or a pool. And whatever designation we give that, we will record it in the next section there that says the type of stream we're dealing with. When we go to reference number 2, we'll do that where that stream changes from whatever we decided that was to something else. So that when we measure, if we say that's a riffle right there, that's going to remain reference number 1 until that stream changes from a riffle to something else. And it might be, who knows how long. before it changes. So we will, in the information gathered here, we will say, well, that riffle exists for the first, and what I'm afraid of is that it'll exist for the first 100 feet, and our whole survey will have one entry.
So,
Do people's assessment of those, do you have discussion about it sometimes? You say, do you think it is a bit of a riffle or a bit of a glide or a bit of a...
Absolutely, and especially when you first get started, it's probably best to have that discussion and come to a consensus, because what you're doing by doing that is training your trainers, so that when you're all scattered out and you're no longer together, you've all had that discussion and you kind of have told yourself what a riffle and a glide and a pool look like.
So under RF, we just put 1 or 0?
Sure, that would be number one.
so probably a better code paint might be 1, and if you're gonna start with a riffle, 1R riffle. Then you go to section 2 is what? 2G
There's a
is,
place on there for defining what it is.
I don't understand the difference between width and channel.
Okay, so,
where?
width.
I don't know.
No, there is not.
Okay, so HT is what we're talking about. The next, hold on a second, I'll answer your question. So we put down, under RF, reference number, we put down 1. HT, the next blank, is habitat type.
Which
And
would be
that's that riffle,
Glide.
run, or glide.
Okay.
So that's where you would define this area that you're talking about. Now, his question was, what's the difference between channel width and width? Okay, so the difference between the width of the stream and the channel width of the stream is the width of the stream currently is whatever from the wetted surface on one side of the stream to the wetted surface on the other side of the stream. So today the stream is a certain width wide. That's why we have these sticks, because it makes it real easy to measure versus trying to take a tape measure with 2 people and hold it there. So if the stream were really wide, you would put this stick where the bank is on this side, you'd come to here and you'd flip the stick over and you'd look to here and you'd say, well, the wetted width of the stream is 5 feet. The channel width of the stream is when you look at both banks of the stream and you see how high the water has flown or where the normal channel is, usually where the edge is cut off or something. The channel width of the stream is usually much larger than the current wetted width.
So it's like where the stream bank starts to...
That's stream bank to stream bank is the channel width. The width of the stream is the current wetted width of the stream.
Which is obviously going to vary from
Vary
week to week
from
to whatever's
constant,
happening with rain,
constant.
etc.
So what we're recording is what's today.
Right. The important thing in my mind would be understanding the channel width as a constant, because that really, how you assess that all the way up does not change, correct?
That's right. I mean,
Channel width.
Yeah, channel width, and you do have to make some guesses. Looks like this is where the channel width is normally, and obviously under extreme flood conditions that changes also. But the normal width of the channel that handles the water. Okay, what's the next?
D.
And just ask questions as we go.
Okay, so we got width, depth,
Width and depth.
and then length of the habitat type.
Yeah, width of the channel. So now we're talking the wetted part of the channel, and we go with this stick and we measure how far it is wet side to wet side.
Okay.
Channel depth is the next question.
Yeah.
What if the depth varies in one riffle?
Well, here's how you're supposed to do that. If let's say the stream is as wide as this table where we're going to be measuring, so you'd come off the shore a little ways, you'd stick this in the water, and it says 2 inches deep. And then you come in the middle and you measure it, and it's 6 inches deep, and you come over here and it's 2 inches deep. Now, all you youngsters that have been paying attention to math, you're supposed to add up those 3 numbers, divide by 3, and come up with an average, and report the average to the recorder. So you got 2, 2, and 6. What's the average?
5.
3.33, yeah.
There you go.
3.33.
So 6 plus 2 is 8, and plus 2 is 10, divided by 3 is 3.33.
Our Boy Scouts are
There you go, there you go. So that's how all that math crap they've been teaching you is going to come in handy in the real
So
world.
No way.
we'll use decimals?
I would round it to the nearest half, you know, put it down as 3.5, because 3.33 in the scheme of things is not a big deal. Now, the next piece of data is length.
How long that certain riffle is?
How long the stream? Yeah, if we say that this is a riffle starting right here, and we go up this stream for 50 feet before it changes to a pool or a glide, when we see it change, that's how long that feature will be, 50 feet.
Are we only making one notation per reference number?
Yes,
So if you've got a hell of a long riffle,
that might be
you've got
it.
one measurement of,
You got one
taking your
measurement.
average of height.
Yeah. Now
Good
you
job.
could shout up to the note taker, oh, by the way, in the habitat type on either side, they might not talk about having a riprap bank, and riprap means these large boulders that are put along here. So that might be something you'd want to tell the note taker to put in the notes. The stream bank on the left side is riprapped and with 2 foot high rocks, and it's riprap 4 feet high. That would be something you'd put in the notes.
Should a recorder maybe carry like a blank piece of paper to record?
You said
Absolutely, on the back. So now the way the recorder references his notes is we're talking about the first section of stream. So he writes a number 1 on his notes, meaning that he is talking about
great.
this first section here, and he's going to put any notes in there in that first section that apply to that. If there were a pipe in there that was drawing water out of the stream and using it to water a garden, you'd make a note. If there's a pipe flowing into the stream there, you would take your stick and you'd measure it and you'd say it's a 6-inch diameter pipe and it's plastic or it's cast iron or whatever it is, and it's dumping water into the stream. If you see any unusual color or moss or pollution or unusual events, you could put that in the notes.
Yes, bubbles.
If you see any creatures, fish, crawdads, frogs, salamanders, whatever, if you see something in there, tell the note recorder to make a note that at river mile, whatever it was, you saw this animal in there. Because this data, the data that was done on Miller Creek has been used by just a ton of scientists. I mean, kids that are going to universities that are studying this kind of work, they don't have access to the kind of information you're going to get out of this survey. So they find our information online and they call us sometimes and ask us about it, but they actually use it as part of their studies. And there may be a biology student that says, oh my God, you mean you actually found such and such a kind of salamander in your stream here? And you took a picture of it, and the picture's also on the website. You and I don't know what that salamander is, but some biologist may see it and go, wow, that's amazing. So record what you see. We're doing the original kind of science here. Do you know what kind of science the original science is?
Field science.
Observation. Back in the day, when the guys that figured out that the Earth went around the sun instead of the opposite, and that all sorts of phenomena existed in the world, they didn't have the luxury of going to school and having somebody teach them all this stuff, because literally there wasn't anybody that knew it that could teach it to you. So the way the original scientists figured out a lot of this stuff is by observation. And so what you're going to do on this project is not only use some known science, but you're also encouraged to use the science of observation. Record what you see. And maybe it won't make any sense to you, but maybe as somebody puts the bits and pieces together, all of a sudden, wow, there's a little revelation there.
I have a question. If you have a long riffle,
Yeah.
at what portion do you measure the depth?
Someplace that looks average. All we're looking for is average.
You go up 2 or 3 sections, or you just measure it once?
Oh, if I were in a long riffle, I'd kind of look the riffle over and say, this piece of riffle kind of represents what the average part of this thing looks like, and I would take my measurements there.
You just take one measurement per.
Yeah,
for reference.
Okay, so now what are we going after
And
next?
can we just back up for 1 second?
Yeah.
On habitat type down below, they
Yes.
talk about bedrock, silt, and so on, but up here we've been just talking about riffle, glide, and so forth. Are we not?
We're gonna get to that question when we get over to SBST, that's substrate.
Oh, I see. Okay, fair
Okay,
enough.
we're
Yep,
gonna talk
thanks.
about what this bottom of the stream's made out of.
It's not bedrock.
Pardon?
It's not bedrock.
We got an expert here, so that'll help.
Well, there's no bedrock around here.
Right, it may be hard clay.
Yeah. Okay, so we got the length of the habitat thing, then we got the channel width and channel depth. Now, channel depth is a little more difficult to ascertain. What we're talking about when we're talking about remember this, the wetted stream, we measured it in 3 places to figure out an average to figure out how deep it was. Now we're talking about the channel width. In other words, the capability of the stream to carry water. So you have one bank of the stream here, and you have one bank of the stream over there, and that's the channel width. But now the average channel depth, what you have to do is draw a line from where the water flows in that channel on this side to that side, and have a line there, and then measure down from that line to the bottom of the stream in 3 places and take that average also. So in other words, what you're looking at here, the first depth measurement we took is, on average, how deep is the piece of water that's flowing down the stream? Next question, how deep is the water when the stream is flowing bank full? Okay, so that's the next question. And to be able to do that, you have to kind of draw a horizontal line from one side to one side. Sometimes when we did that, we actually had one guy kind of hold his stick where we thought one bank was. Walk stand out here in the middle, and he goes, well, you know, there's the bank on that side, and there's the bank on that side. So that's about how deep the channel could be. And then another guy comes up with his pole, and he takes his 3 measurements to that stick, and he says, here it's 2.6, and here it's 4 feet, and then you average that, and that, what you're looking for is how much water, when that thing's bank full, how many feet of water is it handling? That's what that question means.
Are you better calling out inches all the time, or feet in inches, or what did you guys find?
You
'Cause
know,
I could see some.
We
errors.
marked our sticks in decimal, and that, I don't know that that was the best thing, because when I was
We're in
working
inches.
on this, we're in inches.
Talking inches.
You
maybe?
know, scientists talk in metric, and volunteers talk in inches. So, my mind works a little easier in inches. I've never been able to quite convert to metric. So if you've marked your stick in inches, let's just say we're going to do all of this in feet and inches. Okay? And it doesn't really matter, as long as it's consistent, we're good.
Let the computer straighten it out.
Let the computer straighten it out. Somebody looks at this and wants to convert it to metric, they can do that. Okay, so now what's the next one? SS.
SS is,
Stream
side structure. Stream side structure.
yeah,
So now SS, the first thing it's what it's asking you for is what's the habitat look like on 100 feet on either side of the stream. So the first question under SS is no riparian zone. Does anybody know what a riparian zone is?
so trees are down.
It's all of the habitat that's next to a stream. That's the riparian zone, is whatever vegetation habitat lives next to the stream. So when it asks you to describe the stream side structure on either side of the stream, and you look at this first section here, and you're asked about 100 feet back, a parking lot would usually be called no riparian zone. Okay, like, that's not what you're looking for. Now, in your notes, you might say that we have 10 feet or 5 feet or 6 feet or whatever of salmonberry growing, and beyond that, we have an asphalt parking lot. So, if I were to be standing right there where the tunnel is, and
Now, part of the problem is we're maybe describing 50 feet, and so the habitat changes. That's what the notes are for. The other thing you could do here, if you want to further define this, is not because of changes in the stream. The stream may be a riffle for 50 feet, but if you wanted to further define the habitat because it changes, you could call that riffle 150 feet long, but then you could put a 1A down here and answer the question about the habitat on either side, and say for the first 40 feet, it's a parking lot on the left bank. And then you could write a 1B and you say, you know, the next 40 feet of this is, describe it as shrubs and whatever number. So then what it asks you to, what you get to determine from a streamside structure is no riparian zone, which means pretty much parking lot or building. Put a 0, indicate a 0 if it's a lawn, a road, or buildings. Mature complex forest, immature even-age distributed forest, 3 is shrub dominated, 20 feet high, 4 is grassland meadow, and 5 is wetland. So those are your 3 choices, or 5 choices. That's what the notes are for. If it's more complicated than that, write it in the notes.
So would you say that like this area, if we weren't near the parking lot and we were just upstream, it would be probably just mature forest usually, or?
Well, let's see what, where's those other notes?
I would call it immature.
I call it immature.
Okay, I have
Even
some
age?
other notes here, and let's see if we can figure that out.
Mature forest would be hemlock and red cedar,
Okay.
and it's mostly alder up there.
Right.
Up here.
So it's immature then.
It's immature.
Yes, what happens is the alder tend to grow first, and then the alder has a 30 to 50-year lifespan. All the leaves from the alder hitting the ground rot and change the acidity of the soil, and then the alders die and fall down, they rot. They further change the acidity of the soil, and they're preparing the soil for the conifers, which are your cedars and your fir trees. So the alders come first. They spend 30 to 50 years preparing the soil. Then the cedar, the non-deciduous trees come afterwards. So this is an immature forest. There was a forest here once. It's not here anymore. It's been logged off. Okay, next bit of data. So left bank, right bank, habitat it's asking us for, what kind it is. The next thing is SBST, and what that means is substrate. Okay? And so the way, and the options you're given is the dominant substrate in the stream. What's substrate? Anybody know what substrate means?
Gravel or sand, whatever
The
is
bottom?
at
The
the
bottom of the stream. What is it's asking you what's the bottom of the stream made of. So if it's bedrock, you would put number 1. If it's silt and organic, you would put 2. Silt is sand.
What's the easiest way to tell it? You usually
I'm going to
just...
tell you. I'm going
Okay.
to tell you.
Well, you can feel it. Silt is slippery.
Yeah,
Okay.
silt and organic. And organic means rotted leaf material and that sort of thing. Silt is slippery. It's kind of like mud. 3 is sand. 4 is gravel. And what that means is gravel 25 millimeters and smaller. And that's,
1 inch.
I'm glad you know that. I think I wrote that down in here in my note.
2.5 centimeters.
I'm glad we have a scientific type here. Even being an engineer for all the years I was, I could never remember all that.
Have conversions on the phone?
Oh yes, so I on my little adder sheet here that you guys can make copies of if you want, it says gravel, number 4 choice is gravel, less than 25 millimeters, and I wrote less than 1 inch. And then 5 is gravel, 25 to 100 millimeters, which is 1 to 4 inches. Cobble is 4 to 10 inches, and a boulder is bigger than that. Okay, so now, to your question,
Yeah. not inches, it's
Okay,
millimeters.
so simple, Hank, just thinking about it, if it's thumbnail size.
Hold it.
If it's thumbnail size or less, it's probably less than an inch, okay?
Okay.
And you do have your stick here with marks on it, so if you want, you can kind of take a. Now, to your question about, well, how do I determine that? What one of the people in the stream needs to do, and you probably need to assign tasks to the people in the stream. Some people are going to measure width, some people are going to measure depth, some people are going to take the substrate sample, so that you're doing the same tasks as you go, so you get good at it. To determine the substrate, you go out into an average piece of the stream, about in the middle someplace, maybe you stick your hand in the bottom and you take a handful of whatever's there and you look at it and you answer in one of those 5 descriptions. You know, what do you got in your hand?
So silt's even less grainy than sand. It's like
Silt
fine.
is more of that organic, rotted, muddy
Okay.
type stuff.
So it's made, most commonly it's made from clay. It will be slick. You'll be able
Yeah.
to feel it. It just slides around.
So
Okay.
you know what sand is, like beach sand,
Yeah.
and that's different than mud.
Uh-huh.
Okay,
Okay.
so mud is silt and sand is sand.
It's really just loose mud.
The silt will make
Yeah.
you slip and fall.
Yeah. Yeah. Okay, next piece of data.
Uh,
Pool quality
quality
index. Okay, here we go. And what are our choices? Where's my little cheat sheet?
You've got large witty debris.
We're going to do pool quality index here. So, if you find a section of stream here that you would define as a pool, next thing we have to do is give that pool a rating. And what you're giving it a rating on is from the perspective of a juvenile salmon, little guy. And basically what you're trying to describe is how suitable is this habitat for a small salmon to live in. And
So
so
this
you
wouldn't
get
come in on a riffle.
no, this would
This
not
would
come
only
in.
be
So
on a
this
pool.
so only if you had a pool would you try to further describe the quality of this pool. And like I said, you're determining that these assessments are based on not what a human being thinks of the quality of this pool, but what a juvenile salmon thinks about the quality of this pool as a place to live for 18 months. So your choices are no pool, so blank. So now for a pool to get a rating of 1, the pool is less than 1 foot deep. Okay, less than 1 foot deep. It's less than 5 to 25% of the total wetted stream width. So what that's saying is, my stream is this wide, but this pool only occupies one little corner of the wetted channel there. So it's only a small pool in relationship to the width of the pool. So from a juvenile salmon's perspective, that's not as good as a bigger pool. It's like living in a shed out behind the house versus living in the mansion. So it's only 5 to 25% of the width of the stream, and there's no vegetative cover hanging over it. No vegetation hanging over it. If you were to rate it a 2, it's going to be deeper. It's going to be 1 foot to 1.5 foot deep. It's going to be up to half as wide as the stream, and it's not going to have any cover over it. And you can see as you go up here, a 3 is 1.5 to 2 foot deep, 50% to 75% of the stream width with moderate vegetation cover. A 4 is a 2 to 2.5 foot deep stream. The pool occupies 75% of the width of the stream, and it has moderate vegetation cover. For a small stream like this, to have a rating of 5 from the perspective of a juvenile salmon, is that it should be 3 foot or more deep. It's as wide as the wetted part of the stream, so it's a full width pool, and it has excellent vegetative cover. So if you're a little salmon, that's the kind of place you're looking to live. And the reason that is that deeper water gives you a place to run and hide from predators. You might be working food along the shoreline in an inch or 2 of water. You see a shadow, you see a predator, something tries to grab you, you dash into that deep water to get away from it. So having that deep water handy is a place to run and hide. The same thing with the vegetative cover. Not only does it shade the pool and keep the temperature cool, It allows bugs to drop in the water for food source, and then also all the avian predators, all the birds that want to attack you from above. It's a lot harder for them to get at you when you're underneath a bunch of bushes. So that's how they determine that. Next one is large wooded reeds. Just ask questions if you've got any.
Pool quality index strikes me that obviously depending on the height of the stream when you're measuring,
Yes.
it's going to vary dramatically, isn't it?
Yes.
Goes back to the date.
Yeah. I would say today is kind of an average flow for this stream, maybe a little higher than normal since it's still springtime. So if you were able to find a pool in there that was 3 feet deep today, we're not looking for the unusual circumstances of flood. We're trying to assess the stream based on what a small salmon would see throughout a 12 to 18 month time. And probably the best assessment is, what's the worst case? The worst day when there's not a lot of water in there. Today's average, a little above average. If we can find a pool in there that's rated 5, let's celebrate that. Like I say, it's not a science of millimeters here. It's our best estimate, our trained estimate. Now, large woody debris. First of all, a piece of large woody debris, and I can't remember the exact numbers, but it has to be like at least 10 feet long. So again, your sticks, kind of give it a quick measure. At least 10 feet long, and I don't remember the exact diameter, but for this small stream, let's say if it's not a foot in diameter, it doesn't count. Okay? So 10 feet long and a foot in diameter.
So it leaves you room to write one large woody debris per.
You would record
reference.
every one of them.
Okay, but if there's
but
if
there
there's
may
more
not
than
be
one,
one.
you would just do it in your notes.
Is that correct?
Oh, yeah, there probably isn't. I mean, we did the first 2,000 feet of Miller Creek, we found one piece of woody debris in 2,000 feet.
Oh wow.
Now you go back to that same section of stream since we've worked on it and we've let Mother Nature add stuff. I think the last time I looked in there was like 79 pieces of wood in that same piece of stream.
Now, the woody debris has to be wetted?
Yes, yeah, that's a good point. Wetted, in other words, it's got to touch the water or it doesn't count. Now, if the end of a big log is laying in the water and it's 10 feet long and it's more than a foot in diameter, then count it.
Yeah, as long
Yeah,
as it's in the
it's-
water.
as long as it's in the water. So it's asking you, LE says, what is the length and feet of that log? Okay, so you take your stick, dot up, it's about 12 feet long, it's about 15 feet long, whatever it is. The diameter, again, the stick, you put the thing at the end of the log and you look and you say, well, that's 18 inches in diameter. And stability. It's asking you whether you think that this log that you're looking at is anchored or whether it's unanchored. And what
What happens if we have like half of the log? Like we've seen that sometimes, and we have like it's 6 feet up and like I don't know, 12 feet, 12 inches across.
6 feet long?
Or no, 6 inches tall and like 12 inches.
It's like a piece of a log. Like
Piece of a log. So if it's not at least a foot in diameter and at least 10 feet long, we're not counting.
Oh wow.
It's
Got to be
just
like
a chunk
trees
of
in
wood.
there.
Yeah,
Yeah.
it's got to be.
But that
Because,
could be in your notes too,
Sometimes
chunks
you
of
have
wood.
like half of the tree, like half.
So you
oh, it's
just record
split in
that in your-
two or something
Yeah.
like that?
So it's
And
like
it was in the
longer.
water and it was substantial size. I'd probably count it.
Because that's going to affect the water flow.
Yeah, right. If it's really affecting the water flow and there's a pool being dug around it and it's kind of doing its job, I'd count it.
So anything else, you just record in your notes. If it's smaller, you got.
I think if you look at it and you say that this piece of wood could, at the next flood, would likely wash out of here and end up in Puget Sound, I wouldn't count it.
Okay.
Because it's not really affecting the livelihood of the stream. So now if you see a large piece of wood in there that does count, you have to answer this anchored, unanchored question. Well, tell me what you think could anchor a log in that stream naturally. How would a log be anchored naturally?
Could have roots in the bank.
Could it have roots in the bank?
It would be blocked up by rocks. Rocks would be pulled.
Yeah, it could be jammed in between some rocks, and it looks to you like even with high water, it probably wouldn't be dislodged very easily. It could be covered by mud.
wider than the stream?
Yeah, if it's wider than the stream and it's kind of jammed in and it looks pretty good, you might call that anchored. If it's just laying in the center of the stream on top of the rocks and it looks like a high water event could move it, then it may be, you may qualify it as unanchored. If the log were 4 foot in diameter, you know, I mean, are 6 foot in diameter and 30 feet long and lay in the middle of the stream, it's probably anchored. I don't think you ever get enough water in there. Because now think about it, to get that log to move, the water has to, you've thrown a piece of wood in the water, and usually when you throw a piece of wood in the water, it sinks about halfway. So now you have to imagine if you had a 6 foot diameter log in the water, that you would need like 12 feet of water to buoy it, and that's not likely to happen. So that's such a big piece of wood that you'd never get enough water in there to lift it. And then there's always the unknown. So if you don't know, you put down unknown. And then variety, if you can determine the variety of that log, and I think you have some experts here. Really what they're looking for is it deciduous. What does deciduous mean?
It doesn't lose its leaves. Or does lose its leaves. Does lose its leaves.
And what does coniferous mean?
Doesn't lose its leaves.
Exactly. So coniferous is pine trees, cedar trees, things like that. And why do they want to know the difference of a log and a stream, whether it's coniferous or deciduous?
How much matter it's going to add to the stream?
Acidity and a basic, because coniferous are very acid trees. They're leaking a bunch of acid material into the stream.
Basically, I think the reason for this question is because the deciduous tree is going to last 5 to 15 years. The coniferous tree might last up to 200 years. Wow. In the stream. So these alder trees, maple trees, and what have you, if there's a log in that stream made of that material, 5 to 15 years it'll be rotted away. If a big old cedar drops in that stream, it could be there forever. Forever, unless it washes out. I've seen pieces of cedar in Miller Creek there that were original old growth, and they've been buried in the bottom of that stream since they were originally logged or blew over, you know, probably a couple hundred years ago. And there's, I mean, you take your pocket knife and stick it in it, and it is still hard cedar. It's amazing. And then the CN, it says, you know, tell me the how long ago it fell in there. You know, is it solid? Is it about to rot apart? So really, what you're trying to determine there is how much longer is this piece of wood going to feed her? Is it rotted and about gone, or is it in really good shape? Okay, did we cover them all? TY is type.
Yep. Let's see over here. It says whether it's a log jam, floating, stranded, bridged, collapsed, partially,
Okay, so
stump.
yeah, so basically there under type is it's asking you, let's start type. Is it part of a log jam? Is it just a log that floated down the stream and it's currently stranded on a little pile of rocks and the next big rain will wash it away? Was it part of a bridge that collapsed that was made out of logs? And I think it's the most important thing are the sizes, the variety, and the current condition. Okay? Boy, talk about a fire hose job.
Man.
The only way to learn this is to practice it.